All right, let's dive right in. Today we're talking about a really powerful, but honestly, often overlooked section of the National Electrical Code. This is one of those little gems that could save you a ton of time, materials, and yeah, money on your next duplex project. We're breaking down NEC 220.85, the two-dwelling unit rule. So let me just ask you this straight up. Have you ever calculated the service for a duplex? You run the numbers, and you just get this feeling that the final number is, well, a little too high. Trust me, you are not alone. That standard calculation might actually be costing you and your clients way more than it needs to.
And that feeling, right there, that's what I like to call the dual-dwelling dilemma. It's a super common scenario that a lot of us run into, and it all comes from how we're taught to run the numbers from the get-go.
Okay, so here's the core of the problem. When you run a standard load calculation for two separate units, following all the regular rules in Part 3 of Article 220, the math often spits out a number that points to a really, really large service. And what does that mean? It means bigger wire, a bigger panel, and just higher costs all around for a load that in reality might never even be reached.
And this visual, man, it just says it all, doesn't it? Over on the left, you've got that big, beefy, code-required, calculated load. But then, on the right, that's reality. That's the typical, actual load that the two families are going to use day to day. Now, the code is all about safety, for sure. But that huge gap between the calculation and reality, that's where inefficiency and a whole lot of unnecessary cost creeps in.
So, how do we fix this? What's the move? Well, the good news is the code itself actually gives us a really elegant solution. So let's properly introduce NEC Section 220.85. This right here is the key. The NEC basically acknowledges this exact dilemma and gives us an optional method. And I really want to stress that word, optional. It's a tool that's specifically designed to bring our calculations more in line with the real world, all while keeping those top-notch safety standards the code is known for.
All right, so what does this rule actually say? Let's roll up our sleeves and get into the specifics. It's time to decode the language of the code itself.
And here it is, straight from the 2023 codebook. I know, that is a mouthful of code speak. But hey, don't get bogged down in the jargon just yet. The real magic is in that last little phrase. The lesser of the two loads shall be permitted to be used. That's our green light. It's basically giving us permission to do a little comparison shopping and pick the smaller, more efficient option. So let's break down how we get those two loads.
First things first, you got to know this rule has a very specific application. It only works if both of your dwelling units are being supplied by one single service. So if you've got two separate services, one for each unit, sorry, you can't use this method. It's designed specifically for that classic duplex setup with one main feed coming in.
Okay, now for the main event. The entire point of 220.85 is to get you to perform two completely separate calculations. It's not about replacing one method with another. Nope, it's about running the numbers two different ways and then just comparing the results to see which one works out better for you. And that brings us to what I like to call the calculation showdown. We're going to put these two methods side by side, put some real numbers to it, and see exactly how this whole thing works.
Okay, here are our two contenders. In this corner, you've got calculation number 1. That's your standard, by-the-book load calculation for your two specific units. But in the other corner, you have calculation number 2, and this is the special one. Here you get to pretend you have 3 identical units, and you run the numbers using the optional method from 220.84. Why? Because that method gives you way better demand factors. The code basically assumes that with more units, not everyone is blasting the AC and running the oven at the exact same time. And bam! Look at this! This is where the magic happens. Let's just say your standard calculation for the 2 units comes out to 175 amps. Then you run the optional calculation, pretending you have 3 identical units, and because of those more generous demand factors, it comes out to only 160 amps. See the difference? And this is the punchline. The crucial point is right here on the screen. The code is totally 100% crystal clear. It explicitly permits you to use the lesser of the two loads you just calculated. And there you have it. In this scenario, you do not have to size your service for 175 amps. You are fully code compliant installing a service based on that 160 amp load. I mean, that is a real, tangible difference in material cost and probably labor too.
Okay, so let's wrap all this up and make sure we have the key takeaway locked in. How do you actually use this on the job? What's the bottom line?
You know, it's really this simple. If you've got a project with 2 units on a single service, it is always worth taking the extra 5 minutes to run both calculations. Do the standard method, then do the optional method for 3 units, compare them, and the code gives you permission to just pick the smaller number. It is a simple check that can pay off big time.
And this is why it all matters. We're talking about real, concrete benefits, reduced material costs from smaller conductors and equipment, a safe, efficient, and totally code-compliant installation. And the big one? You're engineering a solution based on realistic demand, and you're avoiding that costly oversizing we talked about at the very beginning. It's a win-win.
You know, uncovering a rule like 220.85 really gets you thinking, doesn't it? It leaves me with one final question for you to chew on. What other powerful, cost-saving rules are just hiding there, in plain sight, inside the pages of the NEC, just waiting for us to discover them? Thanks for tuning in.